Hello guys, very good evening. This is Rahul Kumar. I will be the instructor for this 1 hour webinar and will drive you to the knowledge of how this Hadoop actually works, and uh, webinar's topic is highly available and secure enterprise data warehousing solutions. So how Hadoop is working around the data warehousing solutions. So at the end of this webinar, okay, we'll let you know about all these topics regarding what is big data all about, why do enterprise care about big data, why your data warehousing solution needs Hadoop, and then we'll talk about some of the security aspects of the data warehousing solution, how Hadoop maintains the high availability, data warehousing tools in Hadoop like Hive and Hbase. So just introducing about myself, I am having around 13 years experience in Hadoop, big data technologies, Amazon Web Services Cloud, Linux, and Java. Uh, I have given like around 100 trainings on the Hadoop administration side. I'm with Edureka from past around 2.5 years. I've delivered a lot of trainings for Hadoop students. Okay, uh, and I'm based out of India. So that's a bit about me. So now we'll start about this webinar. Okay, if you have any questions, any queries, okay, please drop your questions into this questions window. Okay, at the end of this webinar as well, we'll have a survey. Okay, please do not forget to fill that survey. And if you have any additional comments about it, you can let us know or just from the survey itself, and we'll try to take those comments, as well as any questions. If you have any, you want to talk about later on this webinar, you can please reach out to our sales team, and they will certainly help you, in resolving all your queries. Okay, so in this webinar, I'm going to drive you through a bit about what is Hadoop all about, how it is working as a data warehousing solution for most of the enterprises, and then we'll go into some of the technical aspects of Hadoop. We'll talk about the high availability as well as somewhere about the Hive and Hbase kind of tools. Okay, so let us talk about what is big data. Okay, so we all know what is big data. Big data means, for those who doesn't know, that big data is huge data. Okay, data which cannot be controlled by the traditional on demand database solutions like Oracle, Teradata. So huge data which is not in just gigabyte, which will go into the terabytes, petabytes, and zettabytes. The huge data which is very difficult to analyze, which is difficult to cure, which is difficult to store, which is difficult to process. All these aspects, when you try to do in the big data, it becomes difficult. That is actually a big data. Okay, so big data has got these four characteristics. Okay, volume, velocity, variety, and veracity. Okay, volume, the data which is very much huge in size. Velocity, where the speed of the changing of the data is quite fast. Variety, where you have different form of data sources as well as different types of data, like structured data, unstructured data, semi-structured data. It can be in any form. And veracity, where the uncertainty of the data is always there. You don't know which kind of data will come up in the next 1 hour. Okay, so all these characteristics, if any kind of data, if any kind of data has, that will be called your big data. Uh, where today, lots of data. You all are aware of, like, every individual, how it generates the data from every individual. Even right now, we are speaking on this. We are on this webinar, and everyone is generating the data via this webinar itself. I'm speaking. That is one of the data. This video is going on. That is also one of the data. And you do all the kind of shoppings, or let's say marketing, or banking, finance, insurance. All these things will come up and will certainly add to the sources of big data. So how will you cure this? How will you store this kind of data? Because uh, currently our traditional data warehousing solution certainly has some problems. Okay, the problem is that they are not able to handle it. They are not the solutions which can actually uh, uh, store all these structured, unstructured data. You can do that certainly, but when the data limits goes in petabytes, okay, it becomes difficult to handle that kind of data. You can store it, but you cannot analyze it. Okay, you can analyze it, but the analysis power will take. It will take a huge power. It will take huge amount of time. So we are not saying that RDBMS cannot make sense, but yes, it does not make sense when what you want to store a lot of unstructured data. You want to process images, videos. You want to process other larger files, PDFs, Excel files. You want to process large blocks of natural language text, blog posts, job ads, product descriptions, messages coming from Facebook, Twitter, all these kind of data which will keep on adding, which is so fast and it is coming so fast and so huge that it becomes difficult to even store it in one database. So processing semi-structured data, all these kind of things certainly adds to a lot of different types of data. And RDBMS, it is very difficult to basically store it in some format because all these does not have any format, right? They're all unstructured data, they're all semi-structured data, and they're also having like all the big data properties, all the big data characteristics, right? So it becomes difficult to handle via the RDBMS tools. Then you have got ad hoc exploratory analytics. That's what I just said earlier, that you can store it. Okay, might be that you are able to store it in some form or other, but then it becomes difficult to analyze it. Okay, how will you do the ad hoc querying on the data? How will you do the exploratory analytics? How will you integrate the data from the external sources? Okay, it is not that easy, right? So it's going to take a huge amount of power, a huge amount of time, and then there are a lot of advanced analytics, machine learning tasks as well, which you need to do to integrate this RDBMS with the different data sources. So the big problem with big data is that unstructured, unprocessed, unaggregated, repetitive, low quality, and generally messy, which is actually adding all your problems to the big data. That okay, they are all huge. It's kind of a huge data you're going to process, and the major problem is that it's actually unstructured. Okay, I mean we do handle a lot of data on a daily basis. I do a lot of Hadoop administration on a daily basis, and I see that sometimes even 1 terabyte of data it takes it takes just a couple of seconds to a couple of minutes to analyze that. But when it comes to RDBMS, it becomes really difficult to handle that kind of data itself. Handling in terms of like when you are actually putting it into a database, and then we are trying to do some running some SQL queries on top of it. Okay, it takes hours and hours to analyze it. Okay, yes, it depends upon the machine capacity, it depends upon the hardware capacity, and all those stuff will certainly come into the picture. But generally these RDBMS are not really being created like this. They are not meant for this such kind of huge data. Okay, so technical challenges when it comes into the picture is scalability storage, massive parallel processing, and ready to use tools. So these kind of all problems will come up with the RDBMS. You don't have the storage capacity, you don't have the storage throughput, pipeline throughput, processing power for parallel processing, system integration, and data analysis. So just giving again a brief idea that whenever you store the data in the RDBMS, first of all you have to have some structure into the data. Okay. Secondly, if you're trying to store some unstructured data as well and you're trying to analyze it, you can't do it directly. Okay. You need to, you need to have some other software or something else that which can actually process the data, or you need to write some API for it, and you need to always, the data which basically the throughput which is going to take from moving of the data from your database to application becomes so huge that it will clutter your whole database and the network. So it becomes difficult. And then when this data keeps on increasing, the scalability doesn't come up in the database management. So too many channels for data when you have different data sources. Okay, billions of users, hundreds of millions of users coming from social business applications, coming from finance applications, coming from retail applications, marketing applications. A lot of applications are there. There are a lot of technical challenges when you have too many channels for data. So why do enterprise care about big data? Okay, why it is so important? Okay, this is all like just the data generated by individuals, but why it is so important? Okay, all the logs, they are very important now. Why? Big data is big time important in the enterprise. A whopping 80% of companies say big data is important to their ongoing business operations, with 40% saying it is mission critical. So the reason is, I mean, there is a huge amount of analysis which you can do in the big data, and you can find out a lot of, I mean, you can find out about each and every individual. You can find out about the behavioral aspect of every minute, what's going on really with the big data. Okay, so information is there, but the problem is you are not able to store it, you are not able to cure it, you're not able to process it, and that's why you are not doing it earlier. But now because you have got some tools around it, so you are able to do a lot of analytics like it. Yes, Arpan. So we do have some part about that as well. Okay, but it's not really technical about it only. I mean, okay, so it's mostly, as I told you in the beginning, this webinar will be talking about some of the behavioral aspects of it. This webinar will be about the data warehousing solution, why you are going to choose big data, and when we'll go talk about the high availability aspect of it. Okay. So some, let's say 40% technical, 60% theoretical. Okay. So there is another question from one of our colleagues here. Is saying that, okay, I would like to know about job roles for the developers, analysts, and admin. What is the required skill set for each of these? Does the learning require any hands-on experience? So please discuss this topic. Right. So certainly, Sanam. Okay. I mean, I would always say that, okay, for becoming a good architect, analyst, administrator, developer, certainly you need to have hands-on experience. That is first and foremost requirement. Okay. Uh, the job roles in the big data applications or in the big data area is that you will have a developer's role. So from top to bottom, from bottom to top, I'll take administrator, developer, and then you have got the architects. You have got then the uh, infrastructure architects and cluster architects. Okay, so different roles are there certainly. Okay, where three important roles, I'll say most important in the big data: administrator, developer, and then you have got the architects. Okay, they play a major role because they design the applications, and then according to the hardware capacity of each cluster, they actually create applications and design it. Okay, so big data, got it. Now what? You said RDBMS does not have solution for big data. Then who has? So here comes the solution savior. Okay, Hadoop. I have the solution for big data problem. Why Hadoop? Because Hadoop is a solution that can store large amount of data. It's a distributed architecture, and it has got a processing platform that helps you in the processing the data as well distributed. Okay, so it uses two important components. One is called Hadoop distributed file system, which is a distributed. When we say distributed, means your storage is distributed across the nodes, and MapReduce, which is again a distributed processing part, which basically helps you in storing in the stored data, processing the stored data on different data nodes. So Hadoop has got two different components. One is your HDFS, which is already scalable storage. It's a horizontal scalable storage. It has got replication factors to provide you the fault tolerance, and MapReduce, which in itself is again highly available, and you can also submit your jobs. You can analyze the data using the MapReduce platform. So which in Hadoop version 2 is called yet another resource negotiator, YARN. So YARN is again providing you more generic interface where you can not only run MapReduce workloads, but you can also run some other workloads like Giraffe, Spark, MPP, Open MPP architectures. So you can not only run just one Hadoop MapReduce workload, but you can also run some other workloads as well. So when we say how Hadoop it differs from RDBMS, Hadoop can store all types of data in it. You can have flexibility of the data, analyzing the data. You can drill down the big data to find even the rare insight which was not possible earlier. That's what I just said. So storing is one another aspect. Second thing is you can even process the data. Okay, you can drill down this big data to find even the rare insight of this. Okay, so you can see the difference in the traditional approach and the new approach. So the newer approach basically is more creative, is more intuitive, and you can explore now more insights from this big data. Okay, so sources are there. Okay, different engines are there, but now you can analyze it more because you have got that tool to analyze the data. That's right, Mazhar. So when we say Hadoop stores the data, it means Hadoop distributed file system which stores the data. Absolutely right. Hadoop is the new data warehousing solution. First, load the data, then do whatever you want to do. So the first part before which we say is the ETL. This is ETL. Before loading, you should transform data in particular format. This puts a restriction on the type of data. So this is the bottleneck here. Okay. While Hadoop is ELT, extract, load, and then transform. So there is no need to transform before you store the data. Okay. Transform it later on. So freedom to work with all the data. This is possible because of the cheap storage and distributed Hadoop distributed files. Hadoop is the new data warehouse for all kind of BI requirements. I mean, most of the organizations now have started using Hadoop. Okay, and I can bet that okay, a lot of organizations. I mean, they just use Hadoop for storage and use like its ecosystem tools. For example, Hive, Hbase, Impala, Spark kind of workloads to analyze the data. Okay, so when we say all the BI requirements, I mean Hadoop has got number of its ecosystem tools, number of tools that actually extends the capabilities of its MapReduce platform. Okay, Spark, Impala, and then your Hive, Pig, they are all like some of the tools. Okay, and you can solve most of the RDBMS problems. Like I mean, you can source all of the data from RDBMS or from any moving data, let's say any financial data, banking data, or RFIDs data, sensors data, anything you want to store it directly into the HDFS, you can do it very easily via the Hadoop ecosystem. So the core features of Hadoop are, two, that okay, to get the data. Okay, Hadoop is fault tolerant and when you're storing the data, and super consistent. So that data will get stored on all the data nodes, and they will get replicated as well across the file system. So which means that even if you lose one or two of the data nodes, you will not lose all the data. So you will lose the data only lying on those data nodes, but that will be again replicated because it is already duplicated on other data nodes. So you will not be able to lose that data. So which means Hadoop is as reliable as a distributed platform should have. Okay, it's very much reliable. It's scalable as well. With Yarn, can we have different workloads together in one design workload, as in Impala, Spark, Hadoop all together? Yes, Mother. We do have, and I mean that is the kind of capabilities which Hadoop provides today. Okay, you can have Impala, you can have Spark, you can have MapReduce version 2, you can have Hive, HBase, Uzi, all these kind of things you can have in one cluster, in one design. And a lot of applications. I mean, if you see the Hadoop applications, I don't know if you have seen any one of it. Okay, most of the applications are created by using the different tools only. I mean, it's just not only the HDFS or MapReduce, but it will be always with the help of different tools like Hive, HBase, or Uzi, Plume, Scoop. Some tools, 3 to 4 tools minimum has to be used to create one application for Hadoop. Okay, big data certainly requires big tools, or let's say huge different tools for it. Okay, so now when you have such kind of tool with you, okay, it's very important that when you are storing this data, okay, the components around it, like you have got NameNode and data nodes, where NameNode is the master node of the system and data node is the uh, data node are the worker nodes of the system, where data nodes are going to store the blocks of the data. Means whatever data you store into the Hadoop distributed file system, okay, all the data should get I mean the metadata of that data will go into the name node, and the blocks of the data will go into the data nodes of the cluster. So name node basically stores your uh, blocks to data node mapping, okay, files to block mapping, and then your the locations of the blocks of itself. Okay, so whenever you run any application, okay, so there's a question that where does all these application runs, in which node? All the applications run on the Yarn architecture. What is Yarn? Yarn is composed of two things, the source manager and the node manager. So application runs in the Yarn, okay, data is being provided by the Hadoop distributed file system. Okay, so it's very important that your name node should remain up and running for all the time. If the name node goes down, you won't be able to access the cluster. Okay. So name node is which will store the metadata, data node is which will store all the blocks with data. Combining together, you will have a Hadoop distributed file system that will give you all the data. So Java is not at all necessary to learn all these things, Sanat, at all, guys. Okay, Java is just the, I mean, Hadoop is being created in Java. So if you have some understanding of Java, certainly it will be helpful for learning, let's say, to understanding the problems of Hadoop. Otherwise, it is not at all, really necessary to have an understanding of Java as well. Okay, Yarn can be on different node as well, Dinesh. Okay, so I will talk about it now. Let's say in this scenario, is data node act like read replica or it is same like master? Data node act like read replica here, but it here it is not read replica, Pradeep. It is, let's say, store replica. Okay, it is going to store the replica of the blocks. Okay, master is going to store the metadata. So let's say I'll say file file image. Okay, it's just one image file. So the attributes of the file will be stored into the name node, and the file itself is going to be stored in the data node in the form of block, and block will have certain size about it. Okay, so that is why if you lose the metadata, the attributes of that particular file, you won't be able to get that data. Okay, and that is why we require to have the high availability for this name node. Okay, we should always set up some high availability on this name node. So name node currently is a single point of failure, but uh, you can provide some manual high availability by using the secondary name node, which is actually not a hot standby for this name node, but still you can resolve this issue by getting the data from the secondary name node metadata. But in version 2, if you don't want to keep the secondary name node, you can always bring the Hadoop distributed file system high availability. How to bring the HDFS high availability? Now, HDFS high availability is a bit complicated task, okay, in which you need to have multiple components like this enabled, and it becomes difficult to integrate all these components. So taking an example here, when we want to store the metadata will be written into this name node as well as into this all storage directory. This is a shared storage directory, and here the standby name node is going to read all those directories. So basically both the active and standby will remain in sync, but one will remain active at one point of time, which means if any client is trying to write the data, it will write the data into these shared edit logs, and standby will keep on reading all those logs. So if let's say if at any point of time this name node goes down, active name node goes down, some other daemon which is called zookeeper failover controller comes into the picture and it will promote this standby name node to the active state, because this zookeeper failover controller is already monitoring the health of these name nodes. And to store this metadata of monitoring data, okay, where does this zookeeper failover controller stores this monitoring data? It stores this data into this zookeeper service, which helps these zookeeper failover controllers in coordination. So they coordinate, this zookeeper service coordinates with this zookeeper failover controller. This zookeeper failover controller finds out that, okay, which name node is active and which name node is standby, and accordingly it will take the decision that whether to promote the standby name node to active or not, because then only it will come to know, then only it will understand that, okay, this particular name node is currently down or this is currently active, and this is why we should bring this name node up and running on. So the idea is that the coordination service zookeeper here is very important. So zookeeper only comes into the picture in case of high availability scenarios. Okay, in case of scenarios where you need the coordination as well, where you need the coordination between different components. So for example, here we'll talk about the Hbase as well. We're going to talk about it. In Hbase, in the case of Hbase, we need the zookeeper cluster again, because Hbase require the coordination between its master and slave nodes, which are called as Hbase master and Hbase region servers. So when you need such kind of coordination, okay, you need this zookeeper service. And similar to this, okay, we have got the yarn high availability as well. So yarn consists of two components. Okay, one is your resource manager active and resource manager standby. Okay, Now, whenever you store the data, okay, into the yarn, okay, it's going to write all this data into the zookeeper again. And whenever the data gets stored into the zookeeper, so zookeeper will let you know that okay, this is the data stored. Now, if any job is running onto the cluster, and if somehow let's say your active resource manager goes down, then automatically the standby resource manager will be able to pick that particular job. So today what we are going to do, we are going to just check out the demonstration of how we can achieve the high availability of both these HDFS and YARN. Okay. Now there's one question from Abhilash that okay, how this metadata is being managed across the standby and active name node. So this metadata is being managed with the help of this shared storage. Okay, this shared storage will help both these active and standby name nodes to be in sync. Okay, because at every point of time, okay, both needs to be in sync so that if the active name node goes down, standby should start from the same point where the active has gone down. Okay, so standby will be promoted to the active state with the help of zookeeper failover controller. So in this case, what I have done is I have used three nodes. Here you can see two are my name nodes, name node 1 with the resource manager 1, name node 2 with the resource manager 2, and I have got one data node which is going to store the data. Okay, so just to give you a feel of this architecture, I've created these three nodes where name node is going to provide the high availability between themselves, and resource manager is going to provide the high availability between the resource manager. Yes, so that is what we are going to do now, Arpan. We are going to test this high availability as well after creating this architecture. Okay, so let's see guys how we can do this now, how we can set up this. So here I have got these three nodes. If I just run a small for loop, you can see I've got name node 1, I've got name node 2 and data node 1. Okay, currently this shows Java processes. Are there any Java processes running? No, there are no Java processes. So basically it says that there is no name node running, nothing. Okay, so I've configured some of the things already. Okay, and I'm going to run some predefined steps for this. Okay, quickly. So first of all, I'll run a journal node. Now this needs to be run on all the nodes in the cluster. So there's a question that what kinds of data security we have in Hadoop. We have got every kind of security in ABA. We have got SSL encryption, we have got data at rest encryption, we have got service level security, we have got data level security, we have got network level security. So we have got all types of security available today in Hadoop. Suppose I need to install an application like Pentaho or Uzi on the cluster. Where should I install? That depends upon the architecture, Dinesh. That cannot be explained, straightforward. Okay, that's where the architect come into the picture. That's where the administrators come into the picture, and they collaborate together, and then accordingly they install it. Okay, it's not straightforward. For a name node high availability, how many minimum zookeeper and zookeeper payload controller and how many general nodes required? 3, Arpan. That's what is recommended. You need to have at least 3 nodes for that. That's what I'm running right now. Yes, for any size of cluster. Exactly. Minimum is 3. Now, once the name node is formatted, once we have got the metadata, we can start the nodes, and I need to format the same set of I need to have the same set of metadata for the name node 2 as well. Now, I know that some of the commands, I mean, you guys might not be familiar with that. Okay, I'm just trying to explain that. Okay, what will happen when you run these all daemons. So these kind of processes will come up. Okay, where you can see the name node, journal nodes, and so all these other processes will come up. So you can map the same thing with this architecture now. You can see 2 name nodes are there on 2 different nodes. You can see 3 journal nodes are there on 3 different nodes as well. So 3 journal nodes are there, two different name nodes are there right now, and we'll move ahead now for all the zookeeper nodes. So there is a way to start the nodes as well. The sequence is there, everything is required, configurations are required. It requires a huge configuration as well. And once the zookeeper is started, you will see this quorum peer main kind of Java process also comes up now. Okay, so every different daemon has its own process. Every different software has its own process and you need to run that software. So now basically we have got these general nodes, 2 name nodes and 3 zookeeper nodes. So these all are there. So right now the process, this whole architecture is in standby state. Okay. So general nodes are providing the shared storage basically to this architecture, where all the transactional logs of this name node are being written by the active name node into this shared storage, and the standby name node is just reading all those transactional logs. Now once this is done, you need to start the one of the data node as well to just provide some understanding that okay, the data will get stored into this data node. So once you do this and run a for loop, you'll see now the data node also has come up on the third node, and you have got 3 zookeeper nodes, 3 general. Now in the real scenario, guys, okay, now this is important. In reality, in production, you don't run like this. Okay, production has a different architecture, which we generally teach in our again whole session itself. That, okay, how the production will look like. But yes, this is just to give you an understanding that okay, whatever architecture I've just shown you, same architecture will be created here. So Zookeeper, as I told you earlier, Nava, Zookeeper is involved in providing the coordination between these Zookeeper failover controller. So right now, Zookeeper will provide the coordination between this Zookeeper failover controller. How it will provide the coordination? Let us see that now. Local disk open. It stores all the data on local disks. So now you can see I'm starting the Zookeeper failover controller, and once I start this NameNode 2. Okay, you will see now that Zookeeper is storing some data. Okay, how we can see that? We can use the Zookeeper CLI, and here you will see Hadoop high availability, right? So this is the data. You can see Zookeeper is providing this active standby elector log for the Zookeeper failover controller. Okay, Zookeeper certainly need not to know about the data nodes. Okay, it only needs to about the name node muzzle. Absolutely right. Okay, I've never said that it should know about the data nodes. Okay, can the applications be installed in NameNode? Ideally no, Dinesh. Ideally we do not install anything on the NameNode, and it is not being recommended. But yes, we do have a lot of applications which are required to be installed on NameNode. Okay, there are some applications for that. So in those cases you can't do anything. You need to install those applications onto the NameNode as well. Certainly there is no other way. And right now, guys, if you see this whole architecture is been set up, okay, where NameNode 1 is currently into the active state, and NameNode 2 is into the standby state. As you can see here, active and standby. Ignore the warnings for now. Okay, so this is active and other is standby. Yes, Naba, apart from Hbase, also we use Zookeeper in Solar as well. Zookeeper is being used. Even in Hive also now Zookeeper is being used. So a lot of places, I mean, you can use Zookeeper. Okay. So now the NameNode is up and running for both the nodes. So to see the testing, so somebody was asking that okay, how can we do the testing for this? So what I will do is here you can see the get service state of NameNode 1 is active and NameNode 2 is standby. What I will do is I'll kill this NameNode process here. Okay, simple Linux command kill -9. I will do a hard kill of this particular NameNode process. Now once this is done, okay, and if I go to the NameNode 2 and just try to run this command HDFS HADME get service state of NameNode 1. Let us see what happens. What does it show? Okay, so NameNode 1, I think it will not show because it's not running. So it will say connection failed, connection refused error. This is totally fine. Let's go to the NameNode 2 and see what happens. Okay, so NameNode 2 now has become active. So I think this is what we were expecting, that okay, one of the NameNode will become active and one of the other nodes will certainly, if it is not there, it will not be there. It will be certainly connection refused. Now, if I start this NameNode, let's say the NameNode 1, which is currently down, okay, how the cluster behaves, let us see that as well. So NameNode 1, if we do a get service, you can see it has come up as a standby, means it is not giving the problems to the active one. So it's not mandatory that NN1 will be active, NN2 will be standby. It can be either ways according to the cluster creation you have done, or how you are starting the nodes. Okay. So once this is done, you can see now the whole architecture is in high availability stage. Okay. And the next thing is, if you talk about the high availability for your jobs as well, how we can do that. Let us run some of the other daemons for this. So I'll start one resource manager, and same thing I will do for the other name nodes for the resource manager. So I have a question from Mazhar. Can we give any priority between name nodes which should be active? No. If it is automatically controlled, you can't give that priority. Okay. If it is manually controlled, yes, you can give that priority as well. Okay, that's the difference between manual control and the automatic control. So right now you can see two other daemons have come up: job history server and resource manager. So if we do the same command HDFS, sorry, yarn rm. Okay, I've written that command. Let's instead of that just type it out. You can see resource manager 1 currently is in active state and resource manager 2 is in standby state. Which means now if I go to the web interfaces of these two daemons, 51 and 9026, you will see the resource manager 1 is currently highly available and there is no node manager, so we need to run one node manager as well. I'm sure that you might not be aware of this node manager part, but just thinking that, okay, this is a worker node, this is a worker daemon for the processing. Okay, now even if I try to go to the other node, let's say, just to check out whether the other is in standby or not, you won't be able to see that. You will see this kind of process. This is standby resource manager redirecting to the current active resource manager. So automatically it will bring you to the currently active resource manager. While this is not the case with the NameNode processes, with the NameNode you will see something else. 192.168.0.51. You will see NameNode currently, NameNode 1 is in standby state, which is what we have just seen, and NameNode 2 is in standby active mode. Sorry. Okay, so NameNode 2 is in currently active mode. So even if I try to run any job, okay, it's a framework, Dinesh. That's right. It's a framework to run your map reduce jobs. So if we try to run any job and you will kill that particular resource manager, you will see that they are all in the highly available mode. Okay, that's the benefit. So moving quickly now to the other aspects of this Hadoop distributed file system. So one of the other important point is that how Hadoop is secure. Hadoop is secure with the help of high availability, access control list. Service level authorization is there via the web proxy capabilities, and you can even control it via the access control list. You can use Kerberos for that, for controlling your services, where if the users are not authorized to use a service, they will not be able to. So you can also use quotas, users, and permissions for that. You can use the change ownership commands, I mean the low level Hadoop commands for securing your data. So let's just quickly see a small demonstration of that. Okay, so what I will do for this case, okay, I'll try to let me stop this whole thing. I'll run a bigger cluster for that. Here you can see I've started I've got a 8 node cluster on this single laptop. Okay, I'll not take this one, I'll use 7 nodes for this. And once I start these nodes, okay, you'll see all the different. Right now I have just got, I've shown you 3 nodes. Okay, in this case I've got 8 nodes Hadoop cluster. So this will be much more higher end, and you'll see these daemons on different nodes. So the source manager on different node manager, data nodes on different node, name node on separate nodes, secondary name node on separate node. Like this, it will be come up. So let us take a minute. So what is this access control list, guys? Access control list basically helps you in providing the, I mean, it's basically supports the POSIX level access control list, which is in addition to your traditional POSIX permissions model, which is already supported. So ACLs provide you the fine-grained control of your permissions for HDFS files by providing a way to set different permissions for specific named users or named groups. Okay. So by default, these ACLs are disabled on the cluster, and to enable them, you need to set up some properties for this. So here I'm going to show you how you can use these ACLs. Okay. So now once this all of the nodes are up, you'll see that Okay, this is now I have got 6 node Hadoop cluster, and you will see with the help of this particular command. So you'll see NameNode resource manager, secondary NameNode data node 1, 2, 3, client 1, client 2. So Hadoop, yes, lot of times, Anudeep, okay, a lot of time you need to back up the data. You can use it with the help of Hadoop distributed file system. Okay, that is right, Naba. So image is certainly unstructured data. Okay, now in this case, if you want to start, your cluster, you can use simply start dfs.sh commands. Okay, so this is different, guys. I understand. Again, you might should not get confused. See, this is not a session where I'm going to tell you the internals of all this stuff, but just think in that perspective that okay, this is something our storage is, and this is the processing part we are using. So right now, I have not in this case I have not used the high availability. I'm just using the Hadoop core daemons for this. Okay, so right now you can see NameNode is up. Well, yes, Dinesh. I mean, see, you need to set up the virtual machines for this. Okay, I have set up 8 virtual machines for this, as you can see. All these virtual machines are different. Okay, and honestly speaking, it's not really possible for me to guide the same thing in this very session. It's a very small session for this. Okay. Uh, well, yes, from the sales point of view, I will say that okay, take our course. Honestly speaking, but yes, that's not my thing. I mean, I'm just trying to say that okay, this takes actually some time to set up the cluster. Okay, so it takes actually some time for that. Okay, not a straightforward thing. But yes, I do teach all these things in the first and second session. How will you set up the cluster? How will you create all these things? Okay. Now, once all these daemons are up, guys, okay, you'll see all these daemons on the respective nodes. Okay. So resource manager has not come up somehow on this resource manager node. You can see secondary name node, data node 1, 2, 3, all have their own respective daemons. While client machines, these are the gateway machines. These are the edge nodes where you will not see any kind of users or let's say processes on this because they are not part of the cluster. I mean, they are just the edge nodes where users can come and they can access the services. So in this case, let us first go to resource manager and try to start yarn. Right. So you can see now yarn is also up and running. Okay. Edge node means when you install Pig Hive client side. That's right, Arpan. So edge node means client side nodes. Okay. Do I need to download 8 separate VMs? Yes, Dinesh, you can do that as well. There are other ways of doing it. Okay. This is one of the ways which you are seeing. How much is the RAM for your host Windows? I'm having around 16 gigs RAM, Arpan. Okay. But you can run 8 nodes on a 10 gigs RAM easily. 8 nodes which you have set up has shared memory or segregated. It's one single laptop mother. Okay. It has certainly shared memory. Okay. I'm not using different desktops for that. It's a single laptop. Okay, so now if I have this kind of thing, okay, let's see. Okay, I can get that happen. I understand. Okay, so this is how you will access your file system. So I want to create the directory in the Hadoop distributed file system. I can use HDFS commands. Okay, make directory. I want to put some data into this HDFS. I can use put command. Okay. All the files will go into this input directory. So these kind of things you can do in the using the ACLs. Okay, no, sorry, this is not the ACL right now. This is the HDFS. Now what I want to do is I want to restrict the, you can see currently right now it is for all the Hadoop and supergroup, which is the Hadoop supergroup. I want to restrict this particular directory with some users and group. How can I do that? I can use simply change ownership command. Let's say Hadoop user 1 and developer, I'm saying for the input directory. So this will change the ownership of this particular directory for now. You can see right now it is owned by Hadoop user 1 and Hadoop and developer. Now what I want to do here is I want to provide some more permissions to one other group. I want to say that I have one more developer 2 group, and in that Hadoop user 2 should have only read permissions. How can I do that? I want to say HDFS DFS hyphen set FACL hyphen M, and I'm saying here user developer, sorry, Hadoop user 2 should have only read permissions for this directory. Along with this, I'm seeing that group developer2 should have only read permissions as well. So now I can provide multiple level of permissions to this particular directory. So I can easily see that with the help of getfacl command, I can see that okay, only two users, Hadoop user 1 only have read permissions, and developer group has only got as well read permissions. Okay, that's right, Arpan. Users are pre-created for this. I have already created Hadoop user 1 and Hadoop user 2 for this. Okay, and that's where I can go into the client node. Okay, I can sudo Hadoop user 1. Okay, and here are all my client libraries. Okay, I can access the Hadoop distributed file system for my client machine. Okay, I can create the folders in this. Okay, but if I try to do it with the user 2, okay, right, so this will not work right now because I think it has not been configured for now. That's fine. Okay, anyways, I think the concept should be clear now. So I've not configured the Hadoop 2 user right now. Okay, so this is one of the things for the Hadoop side of things. If you want to secure your files, yeah. So that these are the storage files, Mantesh. Okay, H files basically are for the Hbase. So that is our next part now. This is for the HDFS. Now, just taking a bit about Hbase as well. So I'm skipping to this high part right now. I'm just going to the Hbase and its architecture. So Hbase is nothing but a NoSQL kind of database for Hadoop. Okay, it provides you, uh, you know, uh, all the distributed storage. Okay, I mean it's a database for Hadoop, I'll say. Okay, uh, while the files right now are being stored in the Hadoop distributed file system in the file format. Okay, uh, how about if you want to store that data in some format itself? I mean, not in the file format where you don't want some batch processing. You want the faster processing, like RDBMS, and you want a faster processing as well as you want the data to be stored in some format. You can read the data from from anywhere. Okay, from any position itself. So you can easily do that via the Hbase. Okay, you need to run the Hbase cluster as well. Okay, and you can see here it has also started Zookeeper. Can you see the 3 Zookeeper nodes? And you can get that from this for loop. Okay, you can see the all the region servers have come up now. Okay, you'll also see the, I think this will be a good way. So you can see H master and H core here has come up for this. Okay, and here like this you can go into the Hbase shell and store some data into the Hbase. Okay, so I think we need to continue this session, but I mean I want to because I want to show you some of the prerequisites for this course. Okay, uh, we can always extend this particular thing in our next webinar where can show you how you can provide the user group permissions, user level and group level permissions to Hive and Hbase as well. But let me showcase to you what all what is the prerequisites for this particular course. Okay, you can simply go to the edureka.co website and select our course from here. Not sure if there is some issues in the website today. Anyways, I think there are some issues in the website today, and the prerequisites of this course is just to have some basics of Linux that you need to understand. What is Linux all about? How you can read write the data? What are these commands in Linux? And how will you be able to create a Linux operating system? That's all. After that, I mean, it's all my job to make you guys understand what is this Hadoop all about, what are the what are the things, different components, how you can use the Hbase, Hive, Pig, Scoop, Flume, all these components. So this course is basically having two different ways. There are two things. One, you can go via the weekdays, every day 2-hour course for 12 sessions, and the other way is to use the weekends. So I generally take the classes on weekends with morning and evening sessions with 8 sessions. Each session is of 3 hours. Yeah, Mantesh, I mean, due to some time constraints, I might not be able to show you that, but yes, I mean, probably we'll extend this webinar to next session, and we'll show you some more capabilities about HBase and Hive. Okay. Uh, just out of it, can we set up HDFS on external hard disk? Yes, Mazhar, you can certainly do that, but again, not recommended as it is going to be very, very slow if you are going to set up it on external hard disk. Do you have a crash course like 2 or 3 full days? Uh, Please get in touch with our sales team for that, Arpan. Yes, we do have, I think, for that. Okay. We do not cover Apache Ranger, Knox, or Kerberos security as part of this course. Kerberos security, yes, we do cover that, but not Ranger and Knox. They are particularly related to the Hortonworks data platform. Okay. Uh, but yes, about the Kerberos security and about the ACLs, I do cover as a part of this course. Okay. We do cover some of the Hadoop ecosystem components like Hive, Hbase, Pig, Scoop, Flume. How you can import, export the data from an RDBMS to the Hadoop distributed file system. We do cover that kind of aspect as well. We do cover all the Hadoop specific things, high availability, federation, how you can achieve multiple name nodes in the single Hadoop cluster, how you can do the backup and recoveries, how you can restrict the users with separate uh, putting a lot of huge data into the cluster. We do cover all those kind of things in this course. Okay. Do you have any additional questions, guys? Should you have any additional questions, do not forget to reach out to our sales team. They will certainly help you in uh, you know providing you more internals about what this course is all about and how you can get the maximum benefit out of this course. Okay. There's another question that I loaded the data from HDFS to Hbase using Hive, but I'm facing problem from Pig. Might be Mantesh. So this is one of the important points I want to raise here, guys, that we do not cover everything from your projects. Okay. If you are having questions from your projects, it becomes difficult for us to answer. But anything from related to this course or the components or anything, any of the softwares which we teach in this course, any of the platforms which we teach, if you have anything about that, please let us know. We will certainly resolve it. Do you cover on vanilla Hadoop only or also on Hortonworks and Cloudera? We, as a part of this course, Arpan, we cover vanilla Hadoop, Apache Hadoop, which will help you to understand the internals of it, and then the Cloudera Hadoop, which will give you the idea about the automation aspect of the Hadoop. How will you compare the Hadoop with the Vertica? Any word? Vertica is a NoSQL database merger, okay, like Hbase. Okay, Hadoop is the underlying data warehouse where it stores all the data. For OLTP to HDFS migration, is Scoop recommended, or what's better for parallelism? Scoop only, Kashinath. In all the Hadoop ecosystem components, Scoop is the one that helps you in getting that data. You only take the full course? No, we do have a line of instructors for this, Arpan. Okay, and depending upon the availability of the instructor as well as depending upon the time which you have taken the course, we have the instructors for this. You are the demo. You are for demo, and someone else. No. I am the instructor as well. So Vertica would be having Hadoop. Vertica would be having Hadoop. That's right, Mazhar. Do you help working on the mini project in courses? Yes, we do have that as well, Rishabh. So I think, guys, please do not forget to fill this survey as well as a part of the feedback. It is vital for us. Be it a compliment, a suggestion, or a complaint, it helps us to make your experience better. So I think that's all, guys, from my side today. Thanks all for joining in. Hope you like this session. Okay, we will certainly extend this session for the next webinar where I'll show you more capabilities about the Hive and Hbase. Thank you so much. Have a very good day. Have a very, very good night. Cheers. Bye.